Okay, any questions about the first one? Second one, no repeat, no repeat, no repeat, no repeat. Okay, all of these inputs are unique. So what you're not going to see here is the same input going to two different outputs. As long as there's no evidence that the same input gets you to two different outputs, it's a function.
Next one's not a function.
Okay, let's look at these two. No repeat, no repeat, no repeat, repeat. But it has the same, this is the same coordinate. That was a trap on purpose.
Tricked us.
And that one's not a repeat. This is a function. Because when -7 is the input, guess what the output is? We can predict.
4.
It's going to be 4. Okay, and then this one. I don't see any repeats. That one's a function.
It's a function.
It is a function. Were there any traps that I gave you before? I'm looking for other traps. There was a trap here that we didn't see. Look at the y's are the same. I was trying to catch somebody thinking, oh, the y's repeated, so it's not a function. This one, it's only if the x's repeat. So there's different ways to trap you. Any questions about how to deal with the traps?
No, sir.
So 19 is for tomorrow.
Speak up, because you're away from your computer. I can't hear you. No? Okay. All right, so the next problem looks like this, and I'll have to take the size back down. Let's take the size down to 300. Aha. Which one of these are functions? Oh, these are fun. You're only going to get one of them.
A parabola is not a function.
Yay or nay for the one I'm pointing to?
Yay.
Yay.
Vertical line test, right? Okay, this is a function. What about this one here?
Yay.
Yes, at any one point on my hand, it's touching at one point at a time. There is no location for x horizontally where you're going to have two different points below each other.
What if it doesn't have what if it does have an end? Like, would that still be able to be a function?
What if it has a what?
If it doesn't have, if it does have an end, like it ends in a certain point, would that still be a function?
What do you mean ends?
Yeah.
Like that one, there's not like arrows going off of it, like it's infinite.
Endpoints don't have anything to do with whether it's a function or not.
Oh, okay.
Endpoints or going on forever has nothing to do with the definition of a function.
Oh, okay.
How about the circle? Is the circle a function?
Yes.
Yay.
No.
Yay.
It's not.
Talk
No,
about
no.
why or why not?
Because you do the vertical line test, there's 2 points in the middle.
All these locations, there's 2 points. At x is -2, you have a location here and a location there. At x is -6, you have a location here and a location there, one above the other. Not a function. What about this one? With an endpoint, it's a ray.
Yay.
It's a function.
It is a function.
Yay.
All you have to do is make sure it doesn't violate that rule. What about a parabola? Is a parabola a function?
Yes. Yeah.
This time
Yes.
it is.
It is a function.
What?
Why wouldn't it be? These don't ever go straight up. In a parabola, it never goes straight up. It always has to move over before it goes up again.
Oh.
It'll get steeper and steeper, but it won't ever go straight up and down. Therefore, it's a function.
So, Mr. Rosenthal,
Uh-huh.
I forgot why it can't be a function if it's a vertical line.
It's not if it's a vertical line, what is a line made out of? Points, right?
Yes.
Vertical line would mean you have points that are on top of, above and below each other at the same x. So a vertical line that goes through 3, like that.
Oh.
Whoa, here we go again. See, I'm having tons of
Apparently, it's like the example that Mr. Rosenthal gave us on how something can't raise in temperature when no time has gone by. So if it's just a vertical line, something can't like go up in temperature without.
Well, because it'll have the same X but a bunch of different Y's.
Exactly. Same X with different Y's would give you points that are above and below each other.
Why the circle not a function because it's touching like
Pick
multiple.
Give me an X coordinate that the circle would have a coordinate in. Like X is -3 right here. You're gonna have a point here and a point up there where that has X is -3, Y is 0. X is -3, Y is 6. So there's two different coordinates with the same X value but different Y values.
I got you, my man.
All right. This one, anybody remember what this one's called? It's what it looks like. It's
The step.
A step.
It's a step function. Okay, so it's a function if there is no point above another point or below another point. Is this one a step function?
Yes.
Or is it a imposter? Look, that just looks like one.
It just looks like one.
Look like an impossitor.
What does this open circle mean?
There's not a point there.
There's not a point there.
Oh.
So
right?
it is a function.
So, and then if you move up, that's where the next one begins, all the way till you get to here where there's no point, but there is one above, but there's no point below there. So that's okay. That's a function. That's called a step function.
Are those circles at the end supposed to be there or?
Yes, there's supposed to mean that there's no point there.
Oh, okay.
This
Okay.
next
I
one is
wasn't
an
catching on to
imposter.
that one.
And where did we learn about that? We learned about that on the
On
single
the number
line.
line one.
Yeah, the open circle means it's a way for us to symbolize where there's no point and you want to get infinitely close to that point and show the reader that you can get there's no point. Remember, what's the biggest number less than 4? There is no such thing. Therefore, you can't show that. The only way to show that is by putting an empty circle and shading it, showing that it's infinitely close to that point, but not that point. Okay, let's move over here.
That was a bad boy.
What about just a bunch of dots? Could a bunch of points, by the way, is a bunch of points a relation?
No.
Is this a relation?
No.
Yes, a set of points. A relation is a set of points. All of these are a set of points, all of them. Whether the points make a pattern or not doesn't matter. Whether it's a relation, doesn't matter whether they make a pattern or not. So all of these are relations, but some relations are functions and some are not. So if I just give you a set of points, they could be a function if it doesn't violate that rule. Here, anything below? No. Here, anything above or below? No. Here, anything above or below? Yes. Not a function. Everywhere else, it was okay, but not here. So the whole thing is toast. Okay? Last one.
Not a function.
Not a function. It's just like that one, except that point does exist there, which is right underneath the one above. So there's 2 points with the same X coordinate. 3, 1 and 3, 3. So not a function.
No.
Again, I'm just going to give you one of these, but you should understand it. It could be any one of these.
Wow.
All right, moving along. Remember, you're probably not going to be able to see this video.
Wait, so Mr. Rosenthal, is a parabola always a function?
Yeah. Oh, no, not if it's turned on its side. Oh, you know what? I hit record to cloud. I think it's going to try to. Okay, so I just hit record now. It looks like we're going to possibly get a video from this point on.
So
Okay.
wait,
Sorry, everyone.
what do you mean if you turn it on its side?
If you turn it on its side,
Like it's a sideways McDonald's happy face?
like that, instead of the one that one looks like this. This one, if I make that negative, turns it upside down. This flips it on its side. And then What do you think that one does?
That one, it turns it to the other side.
Okay.
Wait, would it be a function? if
These
it-
are not functions because look, 2 points above and below each other. These are not functions, but they are parabolic.
Wait, so the upside down one is a function? Because there's no point above and below.
This is a function, yeah.
What does it mean if there's 2 points horizontally though, not vertically?
That's fine. It means that multiple x's can have the same answer.
Oh.
What it doesn't mean though is that one x can have multiple answers.
Okay.
Multiple x's can have the same answer, but one x cannot have multiple answers.
Yes.
Those sound to the ear like you're saying almost the same thing, but they're very different statements. Okay. All right. Ooh, I remember these. These are fun. Let me take this down to 375 perhaps. And see if it fits. Maybe 350. Yes, 350 worked. Okay. Can everybody see what it says?
Yep.
Okay. Try to get ahead of me. See if you can do it. I have f of, I'm going to try to color code this to make it easy. Negative 2x plus 4. Oh, that should say f of h of x, not g. That's a misprint.
Over G.
Yeah. Oh,
There
yeah. I saw that on my
there would have to be a g function given to you, and there's not. So this would be either I change that to g, or I change that to h. We could change this one to g. G of x is equal to negative 3x minus 5. What I need is f of g of negative 6. Okay, so the first thing I want to do is take g of negative 6 and find out what that is, right there. And if you notice, that looks just like this, except negative 6 is substituting. So that means it substitutes in the equation. And that's all you're really doing. 18 minus 5 is 13. So g of negative 6 is 13. F of 13, so this, I'm going to rewrite this as f of, take this out and put this in. F of 13 means I'm going to use this equation and substitute for the x. 13.
What?
Why wouldn't I do that?
No, I'm just confused.
Okay, hold on. Go back up to the start. What did g of negative 6 mean for us to do? It meant for us first to go to the g, not the f. That's what the g told us to do. So you're ignoring this.
Okay.
Then it says to substitute negative 6 for x over here. So I substituted negative 6 here, got 13. That's what this is equal to in value. The problem wants me to find what f of g of negative 6 is. We now know what the value of g of negative 6 is, so we no longer need to write it as g of negative 6. We can
13.
replace it with the 13.
Okay.
So notice the black becomes the blue because I now know what g of negative 6 is. It's this. But now we know what that means to do, just like we knew what it meant to do here. It means that we go to the f equation now, ignore this one, and instead of x, put in a 13. So you'll notice I substituted 13 here, right here.
Mm-hmm.
That gives me negative 26 plus 4, which is negative 22. And that's it. There's nothing else to do. So the answer to this was negative 22. This is my solution.
Okay.
It's a problem within a problem.
Yeah.
Any questions about that? Okay. Let's move on. Okay. Oh, good. I can keep the same size here. Notice the names. I usually use my family's names to do this. Jack has a gasoline credit card. So I changed the problem so it's not exactly the problem you see on the test, but it's so similar. I just changed the names of the people, and maybe instead of one type of credit card, I made it a gasoline card, So it's the same idea though. So Jack has a gasoline credit card with a $200 balance. That means that he can only spend at most $200. He can't go over $200. He doesn't have to spend $200. So I'm feeling like this is going to be an inequality.
Greater than or equal to 200.
Maybe it's not an inequality because I'm looking ahead. I see an equation. Gasoline on a given day costs $3.50 per gallon.
Damn, that's cheap.
Well, it's actually cheaper now than that. That's what it was when I wrote the problem. The equation y equals 200 minus 350x is not, by the way, in slope-intercept form because that's not the slope. The negative 350 is the slope. Okay? The amount of money coming off of your credit card has to be negative to take away from the $200 you're starting with, right? So I would rewrite this right away onto my paper as negative. I would write it like this. Negative 350x plus the $200 that you get to start with on the gas card. And that represents, when you do that, let's say I get 1 gallon of gas, I have to take the 350 away from the $200 I have to spend. What's left over is what I have left on the card to spend. So that's why this Y represents how much is remaining on the card after I buy X gallons of gas. So then the problem that you'll be faced with on the test is these A and B here. Identify and interpret the X and Y intercepts. Round to the nearest tenth if necessary. So I need to find the X-intercept and the Y-intercept. How did we do that? 0 and 0. When X is 0, well, if it's in this form, the way that they trap you is they're hoping you pick this 350 or negative 350 on the end. But no, you need to rewrite it. It's the 200 is the Y-intercept. Okay? The X-intercept is when Y is 0, when you've run out of all your money, right? So the Y-intercept is when Y is 0 is when you're on the X-intercept. The X-intercept is when Y is 0, right? So you run out of all your money on your credit card. So basically you're finding out how many gallons of gas will it take to do that. Well, you can solve this. You might intuitively know, oh, I'll just divide $200 by $3.50 a gallon. And that'll tell me how many gallons before I run out of money. Okay, but algebraically, you can add $3.50 to both sides, which would neutralize it here and make it positive here. I'll take the 0. I don't need the 0 there. And then here's where you would get your division. Okay, and you can use your calculator at home.
Mr. Rosenthal?
Yeah.
If we did it on the test, like not algebraically, just like that, just by dividing 200 by 350, is that okay?
I need to see your work. I want you to do it algebraically.
Okay.
About 57.
You do want to go to algebra, right?
Yes.
Do it algebraically.
Okay.
It's about 57.1 gallons. This is what I got on my calculator. Okay. All right. So if it's about 57.1 gallons, now it says identify and interpret. You have to say what these things mean. What does this mean? What is 57.1? By me putting gallons, I've done half of what it's asking me to do. If I just do 57.1, I've answered what the X-intercept is. The X-intercept is 57.1. The Y-intercept is 200. but I have not interpreted them. What is the 200? It's dollars. What is the 57.1? It's gallons.
Gallons.
But that's not enough. That doesn't interpret it all the way. That's only half the interpretation. What is the full interpretation? What does the $200 represent?
How much money he has on his card when he doesn't spend any, when he doesn't get any gallons of gas.
Exactly. Wow, you nailed that one. That's exactly how you interpret it. 200 represents the maximum amount of money before he has before he's pumped any gas. What does the 57.1 gallons represent?
The gallons that he's then bought, and then he has no more money left.
Right. That's if he spends all of his money. That's the maximum amount of gasoline he can put in on the card, charged to the card. Okay? That's the interpretation that you're going to need to put on the test. You cannot just put the X and Y intercept. I warn you, you will not get all the credit for this problem if you do that. Okay. Okay. Any questions about that so far?
Yes.
Hmm?
Why did you put a 0 as the Y?
Because that's what an x-intercept means. It's when on a graph, when you have a graph, where a line hits the y-axis is the y-intercept, where it hits the x-axis is the x-intercept.
The Y is 0.
Hold on. When a possible coordinate for this could be what? Give me a possible coordinate right there.
0, 5.
0, 5 would be here.
5, 0.
Ah, what had to be 0?
The Y, because
Thank you.
Yeah.
What if the point's here? What could that coordinate be?
7, 5. I mean 7,
7, 5 would be up here.
7, 0.
Ah, see what has to be 0?
Yes.
If you don't know where the line's going to hit, then by me saying this part has to be 0, putting it into my equation and finding that, I now know that this is 57.10. See that? What I know is that no matter where it hits the x-axis, the coordinate has to have a y value of 0. And where it hits the y-axis, the x has to be 0. So this would be 0, 200.
0, 200. Wow, that's a big number.
Well, I mean, it doesn't matter. It's just that's what it is. At 0 gallons of gas used, you have $200 on the card. As you start to drive, or as you start to pump gas in, you are dropping your money. This is money. This is gallons of gas. Okay? Other questions about that first part?
Can you explain?
Guys, I'm going to have to mute everybody, and then you're going to unmute and ask your questions. Okay, mute all. Okay, now you can unmute if you have a question. I'm just trying to cut out the background noise.
Okay. I had a question. So, can you just say one more time, how you would interpret the x-intercept?
The x-intercept is when y is 0. So 57.1 gallons of gas is the maximum amount of gallons of gas you can put in the car when you spend all the money you have for the $200 that you have.
What I would have done on the thing was like immediately I would be like 200's the y-intercept, and then I would have said 3.5's the x-intercept. But that's not right, right? So
and it's not even the slope. The slope is negative 3.5.
Okay. So it's asking for x-intercept and y-intercept, not slope and y. Okay.
Correct. Good. Anybody else question? Okay, going to B. Part B, you're going to get a bunch of points. You're going to get, maybe I'll give a point for identifying the X and Y intercept, a point for interpreting, and a point for B. So let's see, for B, predict how many gallons of gas Jack has when the balance on the card is about $80. So when the balance is Y represents the balance, $80 is left. Then you just have to find out what X is to make it so that you have basically taken $120 away, right? How do you get $80 left when you start with 200? You're gonna
You have to subtract
You
120.
shall restore the balance.
You guys, please. This is not the platform for that.
What?
You shall restore the balance. Oh, I see. You were making a joke about this. Never mind. Okay. I would solve this to find, okay, look, watch this. Neutralized, negative 120. Divide by negative 3.5. And a negative divided by a negative is a positive. And then you can use your calculator on the test. 34.3, about 34.3 gallons. Predict how many gallons of gas Jack has purchased when the balance on the card is about $80. So it's about 34.3 gallons of gas. At about 34.3 gallons of gas, Jack will have $80 left on the card.
I went into the hundredths. I rounded to the nearest hundred. Well,
we're going to do it to the nearest tenth.
Okay, only to the nearest tenth. Okay.
Yeah. Any other questions?
Wait, so wouldn't it be 34.4 gallons?
Let's see.
Because it's 34.38.
I got 34.28.
I think I divided on like without a calculator. So
you're pretty close.
Okay.
Any other questions about this?
Yeah.
Go ahead.
Can you move your thing up a bit?
I'm sorry?
Can you move your
Move the screen up a bit, please.
Okay, so how did you get where'd you get the so are you doing between the two equations?
I'm sorry, what'd you say?
Are you doing subtraction between the two equations?
No. There's not two equations. This is not a system of equations.
He just inserted the 80.
This is the same equation, but it told me that there's a balance on the card of 80. So it told me what y is. That's all. It didn't give me a new relationship between the variables in the problem. That would be a system of equations gives you two perspectives and relationships that we know something about two variables in a problem we're trying to solve.
You just do 80 minus 200, then you get 120 divided by
negative 120.
Wait, once again, how is it you go about finding the x-intercept? Is there like an easy rule to always follow?
Yes, make y 0.
Okay.
Since when you cross the x-axis and you're on the x-axis at that point of crossing, all coordinates on the x-axis have a y coordinate of 0. All of them. So by making the y 0, that's what you're finding. You're finding the x, what x would have to be to make y 0 gives you the location of the x-intercept. Other questions about this problem? It's tricky. You got to know your stuff. Once you know your stuff, it's not so bad.
You said for interpreting the x and y intercepts, you just state what
do you mean? What do they mean in the problem?
State their roles that they represent in the problem.
That's right.
Okay.
Other questions? Okie doke.
Seems pretty easy.
Okay. All right. Now to go to some lighter stuff. Doesn't mean you're going to get the points for the lighter stuff. You could still make errors. It's just not You're not trying to wrap your brain too much around all the words and meanings and stuff. It's just, do you know how to do it or not?
You skipped something.
Okay, so they want the slope and the y-intercept,
You
but it's in standard form. I skipped something?
Yeah.
A slide?
Yep.
I'll go back. So let's just do this one. Right now, the slope and y-intercept are not as easy to see unless you put it into slope-intercept form. The way we do that is we isolate y. So basically, I'm testing you to see if you know how to isolate the variable y. First thing I'm going to do is I'm going to subtract 4x on both sides. Neutralized over here. Don't forget that that's negative. A lot of students forget that's negative. They just put 15y and they get it wrong just right there. Second thing I want you to do is switch the order. Using the commutative property, instead of 75 plus a negative 4x, do negative 4x plus 75. Next, I want you to finish isolating y by dividing by negative 15 on the left. By the multiplication property of equality, you must also divide by negative 15 on the right. When you go to the right, you see there's two parts, two pieces to it. So you must distribute your division to each term. Divide by negative 15 here and here. And simplify. So this makes 1y. Here, a negative divided by a negative is positive 4/15. Leave it as a fraction. There's your slope. A positive divided by a negative is a negative or a minus. And that's just going to be 5. So, hello there, Jack.
I'm gonna have to go. Sorry.
Where-
Come.
You okay?
Sorry.
No, it's okay.
Be okay. Don't worry.
He's okay. All right, this is your slope. This is your y-intercept. Don't forget, it's negative 5, not 5.
So, when you're trying to isolate y in these problems, to find the slope, you just
Get it all the way into slope-intercept form.
okay.
And there's your slope. There's your y-intercept with that sign. If it's plus, good. If it's minus, don't forget the minus. Some of you are going to forget the minus. If you say that the y-intercept is 5, you get it wrong. It's wrong. You get it all wrong. You must say that it's negative 5.
Where did the negative go? In the slope.
Negative divided by a negative.
Oh.
Questions? Okay, come along. I'm going to go up now. Graph a line with slope 0.4 and y-intercept negative 5. Okay, so the slope, I think I'm going to take the 0.4 and make that 2/5. Y-intercept negative 5.
Could you have made the slope 4/10?
Yeah. When you graph it, though, you're going to need to go up 4/10. I'd rather go up 2/5.
Okay.
There's negative 5. There's my y-intercept. And then I'm going to go up 2, and I'm going to go over 5. Done.
Mr. Rosenthal,
Uh-huh.
would you rather want us to do the simplified way, like how you converted it to 2/5, or could we do it however we want? Because I did it 4/10
If you
as well.
convert it into a fraction,
As long as your line is in that same location. If I were to go up 4, 1, 2, 3, 4, and go over 10, and you made a line, it would be in the same line. That's because the slope is constant between any 2 points. So between this point and the other point, that ratio, 4/10, is equal to 2/5. So it's going to still be the same steepness. It'll be the same line.
Okay.
Mr. Rosenthal,
Mm-hmm.
when x is 0, what line are you on? Are you on the x or y axis?
What this coordinate is.
That's 0, 5.
Which one is 0, the x or the y?
The x.
When x is 0, you're on the y-axis.
And when y is 0, you're on the x-axis?
Correct.
Okay.
And that's a really important concept to soak in. And it's another concept that students need time to absorb. That's a normal for students to not absorb that completely right away. But at one point, it's just going to be normalized for you. You're going to understand that completely without, it's going to be autopilot for you. You just need to work with it a little bit more and that'll be auto. You won't understand how you never saw it so simply. But it's just like anything else, riding a bike. Okay, moving along. Am I skipping? Oh, I think I'm skipping because it's loading. Yep, sure enough. Okay, we did this page 6, so now page 7. Here we go.
Mr. Rosenthal, wait.
You can do page 5, remember?
Yeah, that was page 5. This is page 5.
It
Wait a
was.
second.
It was.
On page 5, like, does the line have to be exact? Because, like,
What does
the
that
line
mean?
that you. Because for the line that you made, it obviously wasn't like the exact places it didn't cross through the exact places it was supposed to. But on the test, does it have to be like an exact line, or is it just like?
I know what you mean. These are in exact locations. That location is exactly 5, -3. This one is exactly at 0, -5. What do you mean? Do I want your lines to be drawn with a ruler and straight? Do I want your tick marks to be evenly spaced? Yes. Will I mark you off or even mark it wrong if the graph is so messy I cannot see? Yes. If you did it right, but your graph is so messy that it's inaccurate, is it going to be wrong? Yes. All right. So it needs to be an accurate line. Now, with the tools that I have on a board like this, the line's not going to be perfectly straight. On your paper, if you want, use a ruler so that your line is straight.
I'm too by. That's
So, what was that?
nothing.
All right. Yeah, we're definitely not going to finish the review today, but we will finish it tomorrow and take our test on Monday. Okay. What is true of the slopes? This is a weird, interesting question, but what is true of the slopes of segment AB and segment DE if the two triangles are similar? And then explaining why is important here. You're not going to get any credit at all unless you give me the why.
The slopes are the same.
Yeah, it's just different size and you're putting it different angles.
Why would they be
The
same?
angles are congruent, so the slopes are the same.
The angles are, that's an interesting way to say it. Okay, AB, what is true of the slopes AB? There's a slope of that line, that segment, and DE, there's a slope here. What is true of the slopes of those if the two triangles are similar? So you're saying the triangles are similar, then you're saying angle what is congruent to what other angle?
Well, angle D is congruent to angle A, and angle E is congruent to angle B.
They're all congruent because they're
And angle F is congruent to
Yeah,
angle
and
C.
angle F is congruent to angle C.
Yeah, they're all right angles, but they're just flipped.
Well, they could be a right angle. We didn't tell you that.
right triangle.
They always
They're just made smaller and flipped.
Okay, so
They're going to be parallel or.
okay, so what's really cool about this is that in trigonometry and in pre-calc and calc, we are going to discuss slopes as they relate to degree measures. Okay, so I can tell you that when we do vectors in a certain direction, I want to know what this angle is, and I want to know how long this is. So I can draw a right triangle, and I can use the Pythagorean theorem to find how long that is, if I know how long that is and how long that is. And I can find this angle because we're going to teach you how to find that angle given 2 out of the 3 sides of a right triangle. Okay, so then I can talk about a boat going a certain amount, maybe 45 degrees north of the east line. Here's the east line, here's the north line. If I want to go 45 degrees from that line and a certain distance, where will that get me? That will get me to a certain point on the coordinate plane, right? So right now we talk about this point. Maybe that point could be, maybe that point is 4, 3, right? So describing that point as a location of an X coordinate and a Y coordinate is one way. Another way to say where that coordinate is by saying, if this is like the radius of a circle.
11 a.m. Finish the meeting.
It doesn't matter. I have a watch on my hand. I know what time it is. Please do not say what time it is. Okay? We don't stop right at 11. It's a soft target. Okay. So what I'm giving you here is important for the future. Okay. So instead of where we are now is understanding this coordinate is where it is. The slope is how far up and how far over. Delta Y and delta X. Here, delta Y, we went up 3, right? And we went over 4. Slope is described that way. The location is described as 4, 3. Later on, you can describe this as an R, a radius from the center of a circle, which is this hypotenuse, okay? And the angle that you take, or theta. That's a different way of looking at it that you'll do in Algebra 2 and in pre-calculus, okay? Right now, we're not going to do that. So let's finish this problem and then we'll stop for the day. What I want you to know is that the ratio of corresponding sides is equal in similar triangles, okay? So this BC right here over this AC is equal. Now, what is BC? It's the side that's between the 3 and the 2. So the 3 and the 2, that's EF. Over AC here is the side that's between the 1 and the 2 markers. The 1 and the 2 here, that's DF. Those are equal because the triangles are similar. But if you look at what those are, BC is vertical change. AC on the bottom is horizontal change. This is the slope of this line. If you look here, EF is vertical change. DF is horizontal change, which is the slope of this line. So what is true of the slopes of AB and DE if the 2 triangles are similar? What's true is the slopes are congruent. Why? Because the ratios of corresponding sides are equal. Okay, you can write that. You can write that because the ratio of corresponding sides are equal. The ratios of corresponding sides are equal. And that would be your reason why. So I can write that, and then you guys are dismissed, and we're on office hours. The ratios of corresponding sides are, we can say proportional. There you go, folks. And tomorrow we'll finish up the review. We'll take our time. All right, and I'll see you all tomorrow. Great job.
Mr. Rosenthal?
Mm-hmm.
So I said the slopes are the same because the angles are congruent. Would that answer be acceptable?
No, because you don't have a complete understanding of why that's the case.
Okay.
Okay. I mean, I can have the congruent angle, right? And I can turn this, I can rotate this triangle and keep the angle the same. That's called a rigid motion. It's a rotation. Okay. It preserves the angle measure and the side lengths, but I rotate it. And now all of a sudden this slope changes, right?
Yeah.
Mr. Rosenthal.
I guess I could have said the same.
Miss Rosenthal.
I could have said the same if I rotated it and did it this way, I guess. But I guess that wasn't a good answer. Bye, everybody who's leaving.
Will there be vocab on the test?
So no, I think you're right. I think yes, if the angles are the same, the angles aren't in the same location. This angle's not in the same location as its corresponding angle.
Yeah.
Well, you
I
know
just
what?
have to. I
On
just have
the
to.
test, I'm going to give these to you on a coordinate plane, so you won't be able to rotate it away. So you'll see it clearer on a coordinate plane.
Okay. Yeah. I just need to elaborate more on the angles are congruent. It's not exactly.